You got friend in me.
Unit 1, Section 4, Rewriting Equations, otherwise known as literal equations. Literally, that's what they're known as in other places. Do you remember solving for y? We did it in Algebra Section 4.4. If you forgot, you can go back there and watch it. But basically what you want to do is get the y all by itself. Maybe we should write that down. Solving for y. So when you solve for y, you get y by itself. And we do this a lot when we graph. And there's other reasons to do this too. We're going to get into some of those. But the first thing you want to do in number 1, we have 8x minus 2y equals 18, is you have to get rid of that x term. So to do that, we're going to subtract 8x from each side. Remember the goal. We want to get y by itself. So we get rid of that x term, and we're left with negative 2y equals. Now, these are not like terms. So you cannot add them together. You can't combine them. So we're just going to write it out as negative 8x plus 18. And I like to write the x term first so it's in slope-intercept form because we know that's important. Okay, the next step, we divide everything by negative 2. And that'll cancel out the coefficient in front of y. We're going to be left with y is going to be equal to, we have negative 8 over negative 2. That's positive 4. We have the x hanging out. We have 18 over negative 2. That's negative 9. Voila. That's solved for y now. Remember doing that? Let's look at number 2. All right, for number 2, you have 3x minus 5y. They added a plus 11 there. Okay, so you could subtract 3x, then subtract 11, then divide by negative 5. That's 3 steps. Or, watch this. Let's just move that over there. What do we got here? Plus 5y, both sides of the equation. Remember when I say sides of the equation, I'm talking about where that equal sign is. Okay, that divides it in 2. So let's look at the left. We get 3x comes down. The negative 5 and positive 5 cancel. We get plus 11, the equal sign, and we have a 5y. Now all we have to do is get rid of that 5. It's 5 times y. So to get rid of that, we do the opposite, which is divide. The opposite of multiplication is divide. They cancel out. We are left with, I'm going to read it right to left here. We get y, and then 11 over 5. That's reduced as an improper fraction. I'm going to leave it just like that. And we have 3x over 5. I'm going to rewrite that a little bit, 3/5 x. Because again, I like that slope-intercept form. Remember, we graph with it, and it's so fun. But that's it. We did the first 2. All right, now your job is to do the next 2. So pause the video, and do 3 and 4, and we'll check them out. Go. Okay, hopefully you got the right answer because this is old stuff here. For this one, I get y equals 1/3 x minus 14/3. All right, subtract x. Divide by negative 3. Be careful. You have negative x over negative 3. That's positive 1/3. All right, I'm going to write that 14 over negative 3 is minus 14/3. On the right, what are you going to do first? I would subtract 7 and then divide by negative 2. So subtract 7, divide by negative 2. This is kind of tricky because you have a lot of negatives, but you have negative 1/2 x. Remember that x comes down. There's a 1 up there. Negative 1/2 x plus 7/2 because negative over negative is positive. The 2 negatives there cancel. You get a y. So if you're still confused with that, you need to go watch 4.4 from algebra. That's all I can say because this is a review. We've done this before. Go watch that video, 4.4. It'll go through the whole process for you. So what we're doing now, we're going to solve different formulas for letters probably not that you're used to. For example, 5. Area equals 1/2 base times height. Okay, this is great if they give you the base and the height. But what if they give you, we'll say the height and the area, and they want you to figure out the base. Okay, you could do it by plugging in this one and then solving. And then if you have another problem, you'd have to plug it in and solve it again, and then solve it again, solve it again. Or you could actually just solve this for the base first, and then when you plug your numbers in, you get the answer. No extra steps. It's quicker, it's more efficient, and it'll save you work in the future. So solve for the indicated variable in the parentheses. So we want to get this variable all by itself. All right, so let's see how we do that. First equation, we have area equals 1/2 base times height. All right, I want to get rid of the half. So what's the reciprocal of 1/2? Well, it's 2 over 1. Okay, so I'm going to multiply both sides by 2 over 1. So that's going to give me 2 times the area is going to equal, these all cancel out, the base times the height. All right, now this is multiplication, base times height. What is the opposite? How do you undo multiplication? You divide. So we divide each side by h. Guess what? That's it. 2a over h is going to equal the base. And we're all done. That's all there is to it. Well, that's easy. Let's look at the next one. area equals pi r squared. We have to get the radius by itself. So I'm going to divide both sides by pi. Got to get rid of that pi. Area over pi is going to equal, they cancel, r squared. So the question is, how do you undo a squared? Well, if you remember back to chapter 10, we take square roots. And by 10, I mean 10 in algebra. So we get square root of area over pi is going to equal the radius. And we're done. Okay, these are actually easier because you don't have to figure numbers out. You don't have to multiply, divide. I mean, you just write it the way it is. You can't subtract things like that. Let's look at 7. I always love it when I have a half there. Just multiply both sides by 2. So 2 times this, 2 times that. So we're going to be left with 2a is going to equal, they're going to cancel, and we get b1 plus b2 times h. Did we say what we're trying to solve for? We're solving for b1. That's that right there. All right, so we have this resulting equation after we multiply both sides by 2. Let's get rid of the h. Divide by h, divide by h. So now we have 2a over h is going to be equal to b1 plus b2. See where we're going? What's the opposite of adding b2? The opposite would be subtracting b2. Okay, so we're going to subtract b2 from each side. Now, as I said, this is kind of easy. You can't subtract b2 from a's and h's and all that. So we're just going to write it the way it is. 2a over h, and we're going to subtract b2. That's going to equal b1 because they canceled out. We're good to go. That's it. By the way, formula for what? Area equals 1/2 b1 plus b2. That's a trapezoid. Middle one, circle. First one, triangle. All right, let's keep moving right along here. I'm moving fast because we have a lot of examples I want to get through. So 8, we want to solve it for r. So r is right here. Let's divide by pt. Divide by pt. Because look, you have 3 things being multiplied. It's r times p times t. What's the opposite of multiplying? Dividing. So we can divide by pt. The p's cancel, the t's cancel, doing it all in one step. So I over pt is going to equal r. Formula for simple interest. Let's look at 9, slope-intercept. This one's kind of tricky. We have this term plus this term. We want to get b by itself. We have to get rid of that. So how do we get rid of another term? What if that was 2x? 2x plus whatever, and we want to get rid of a 2x. We do the opposite, which is minus 2x. Well, the opposite of this, it's being added to b, you subtract it. So we subtract mx from each side. Draw the line. We get y minus mx is equal to b. Done. Easy enough. You do 10, 11, and 12 all by yourself. Pause the video. Do it yourself. Go! Okay, looking at number 10, I paused halfway through it because I want you to really pay attention to this. We have a 9/5 c plus 32. Got to get c by itself. We got to get rid of the 32, so we subtract from each side. You get f minus 32. That's easy enough. I think everybody's okay with that. The next part's the 9/5 c. To get rid of a 9/5, you can divide by 9/5, but then you get ugly fractions, under fractions, and that just makes it complicated looking. It's easier to make a mistake. So let's just multiply by the reciprocal. Okay, instead of 9/5, we'll flip it over, 5/9. Then they cancel, they'll cancel. You're left with c equals, we have 5/9. Now here's the part I want to be sure to point out to you. You get 5/9 times the whole side, so you have to use parentheses, f minus 32. It's times the quantity, f minus 32, and so we're going to leave it like that. Can you distribute? Yes, you can. Do you have to? No, because c's by itself, so we're all done with that one. Okay, next question. All right, number 11 here. Look, we have to solve for z, and z's in the top of this ugly fraction, blah, blah, blah. If I want to get rid of this denominator, I'm just going to multiply both sides by r. And what that'll do, that'll cancel those two. They'll go away. And that's what we have here. And on the right, we have 1 times r. That's just r. All right, well, now it's easy. X plus z minus w. Well, get rid of the x, minus x, minus x. All right, they're going to cancel out. You're going to be left with z minus w equals r minus x. Get rid of the w. You add w to both sides. We're all done there. Z equals r minus x plus w. Now, if you did it a different way, you could have r plus w minus x. That's okay. That's the same. As long as they're equivalent to each other, we're happy. Okay, number 12 I thought we'd do together because it's so simple. As I said, if you have something in the bottom, just multiply both sides by it. So we're going to multiply both sides by 2 here. The 2's will cancel on the left. You'll get x plus y equals a times 2. Let's write 2a. Do not write a2 because that looks like a squared, which means times itself. All right, next step. We're solving for y. We got to subtract x from each side. So in this one, we're all done. Y equals 2a minus x. And we're done. Hey, look at that. How about an application problem or 2 or 3 or until we're ready here? Number 13, the ratio. Now, this is the most accurate equation I could find on the internet. It's all over the place. But let's write some of the stuff out. The ratio. What does ratio mean? Ratio means you have to divide. Okay, so the ratio of the bounciness of rust. Can we abbreviate that? Let's call that bounciness. And let's use a subscript here. The bounciness of rust. Okay? Ratio means divide. So we're going to put that over the ratio of the bounciness of rust to the magnitude of exposure. Magnitude of exposure. That's one number, but we'll put a subscript there as well. That is equal to the lateral area of the rust particle. So this equals the lateral area of the rust particle. All right, well, let's solve this. Let's multiply both sides by m, subscript e. Multiply both sides by m, subscript e. They cancel. What are we left with? B, the bounciness of rust, is equal to LA M-E. That, if you have Mr. Brust right now and you're in his room, bring him over, show him that. Ask him what he thinks. Next question, 14, the Pythagorean theorem of baseball. This is actually really cool, Pythagorean theorem of baseball, because here's what it does. All right, if you take certain stats and you plug them in, you can predict how many wins the team will get. And I'll show you how accurate it is here. What do we got? The number of wins is W. And the number of runs that the team scores is R. And then you take the number of runs that the opponent scores, we'll call that A, and the total number of games that they played. Okay? So taking these three numbers, we have a relationship here of W over T is about equal to, that's what those wavy lines mean, approximately equal to R squared over R squared plus A squared. All right, solve the formula for W. Well, that's easy enough. It's W divided by T. So we just multiply both sides by T. And don't try to get too fancy simplifying. You'll screw something up. We don't want to do that. So we're going to get here W is going to be approximately equal to R squared over R squared plus A squared times T, whatever T is, total number of games. That's a little A down there. Okay, and in 2012, these are real numbers, the Yankees scored 804 runs, and their opponent scored 668. Okay, and there was 162 total games. We need to estimate the number of wins the Yankees had. Okay, so let's rewrite the equation just so everything's nice and complete down here. Hey, where'd that go? Up there. Let's put it down here. So we're going to plug into each of the different letters the stats that they gave us. So this is going to approximately equal to R squared. R is what? The number of runs they scored, which they told us is 804. So we have 804 squared over 804 squared plus A is, where is it? The opponent's. It's how many runs the opponent scores. 668 squared times total number of games played, 162. So we're going to multiply this by 162. All right, so pause the video, figure that out in your calculator. Go! Okay, so I'm in the calculator here. If I figured out, I did the first part of the equation there, I get 0.59. That's just the first fraction. I need to multiply that by 162. So we're going to do that here, times 162. And we get 95.84. All right, so all this equals 95.84. And if you notice, that's how many wins we're going to get. And they actually had 95 wins in 2012, so that's pretty close. And furthermore, see how that that exponent's a 2? It's actually not really 2. They rounded. It's actually 1.8. They rounded to make your life easier. But if you use 1.8, it's exactly right. And that's just crazy. That boggles my mind. And lastly, number 15. We have done 15 problems today. That's amazing. Fantastic. Total number of miles a honeybee can fly in its lifetime is modeled by the equation. Total number of miles equals the miles flown each day, that's what M is, times the quantity, the number of lifetime, D equals the lifetime of the bee in days. It's how many days the bee lives. And then you subtract 21 and you get this nice little model here. Some bees fly up to 55 miles in one day. That's a lot. That's how many miles per day. So which one is that? Miles flown each day. That's the little m. So little m. And their muscles can fly a total of 500 miles before giving out and they die. So that's T. So we have T and we have M. Solve the equation for D and find the total number of days the bees live. All right, so first step. Let's do that down here. T equals M times D minus 21. Now, just for all you distributive property fans out there, let's do the distributive property on this one. You don't have to. You can divide by, what would you divide by here? You'd have to divide by N. Okay, but then it gets kind of tricky. Now, this is the best way to do it. So we get T equals MD minus 21M, right? Because you use the distributive property. I'm then going to add 21M to each side. We want to get D by itself. That's our goal. So get rid of this other term there. We're left with T plus 21M is going to equal MD. All right, so we want to solve for D. We got to get rid of that M. We divide by M. Divide by M. So, final score here. D is going to equal, putting that up there, T plus 21M all over M. So, using the information they gave us, M is 55. We're going to plug in here. M is 55. We got an, what do we got? T. What did we get for T? 500. So 500 plus 21 times 55 all over 55 will equal D, okay, which is the total number of days that the bee will live. Let's get the calculator up here. Okay, so my buddy, the calculator up, we have 500 plus 21 times 55. Put that in the top. Make sure you use parentheses, grouping symbols with that division sign. We want to divide that all by 55. Final answer, 30.09. So we're going to say that the total number of days that a bee can live, one of these bees, is 30.09, which is just about a month. That poor little bee. But that's it. Let's put a unit on here, shall we? Days. That's always good to do. All right, so that's it. Hey, guess what? No review scheduled for this chapter because it's mostly review. That was really confusing. No review because it's mostly... No, there is no day on the schedule for you to complete the review. There, I said that correctly. So make sure that you do your best. Do it at home. Should be quick. It's a one-pager. You should be good to go. Hey, this is Mr. Kelly Baumholder. Remember, it's nice to be important. It's more important to be nice. So,
my darling, you got a friend in me.